Alright, so you probably have the quadratic formula memorized. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. When we want to evaluate the quadratic formula, we use the a, b, and c value, again coming from the standard form of ax squared plus bx plus c. So when we look, we've got that our a value is 1, our b value is a negative 3, and our c value is a negative 40. We plug it in. This is the opposite of b. b is a negative 3, so the opposite of a negative 3 is a positive 3, plus or minus the square root of b squared, negative 3 squared, minus 4 times our a times our c, all over 2 times our a value. So the very first step, and you want to make sure that you show all of your work for this, is substituting in your a, b, and c value. Don't skip this step or you're going to skip a point. Then what we want to do is we want to simplify this quantity inside that square root sign. And you want to make sure that you have the parentheses where they need to go and how they need to go. And that ends up being 169 all over 2. In this case, 169 is a perfect square. The square root of 169 is 13. So we've got 3 plus or minus 13 all over 2. That gives us two solutions, one when we add 13 and one when we subtract 13. So we've got 16 over 2, which is 8, negative 10 over 2, which is a negative 5. So for this case, we have two solutions. X is equal to 8 or x is equal to 5. One of those two cases will both give us an answer of 0. Don't forget that when you graph this, your solutions are your x-intercepts. So go ahead and pause and get out your calculators and graph it and look at your picture. Alright, we have our equation into y1. We go to zoom 6. We start off with a standard window. We got to move our window down. So that's our y. And let's move that down. I'm going to make it negative 30. See if that fits. No, but good enough for me for right now. We can see where the sketch is going to be. And we see that our graph is opening up, which we would have been able to tell from our a value. We have our two intercepts. Go to second trace, we find the intersection between the line, and then our second curve, we should have 0 and y2. And we get that our first one is at negative 5, 0. And good thing we did this so we can check our answer. Scroll over. If you just hit enter again, you'd get the exact same answer. And we get that our second one is at 8, 0. So I missed that negative, so negative 10 divided by negative 2 is a negative 5. So don't be like me and make sure that you're paying attention to your positive and negative signs. We see that we have two solutions. We have two x-intercepts. We go on to our second one. 3x squared plus 2x equals a negative 5. In order to use the quadratic formula and to find the correct a, b, and c values, you need to have your equation in standard form. So we've got to move that 5 over from the right to the left, where it becomes a positive 5. So a is equal to 3, b is equal to 2, and c is equal to 5. So we want the opposite of b. The opposite of a positive 2 is a negative 2, plus or minus the square root of b squared minus 4 times your a times your c all over 2a. Remembering your first step is always just to show those substitution. So we plug in our a, our b, and our c value everywhere, making sure that we don't skip that so that you get all your points. Next thing we want to do is simplify this number underneath the square root sign. So we got negative 2 plus or minus the square root of a negative 56. Now, if I have a negative inside my square root sign, I know that I have imaginary numbers. I break down 56. We've got 8 and 7, 4 and 2, 2 and 2. So that becomes a negative 2 plus or minus 2i on the outside, 14 left over on the inside, with a 6 on the bottom. Now we've got 3 pieces. All 3 are divisible by 2. If not all 3, then you can't do one of them. So it becomes a negative 1 plus or minus 1i root 14 all over 3. And no, you do not have to have that 1 there. You need that 1, but you have the I component, so you'd have an assumed 1 there. We go to our graph. We plug in 3x squared plus 2x plus 5. Go back to our standard window, zoom 6. And when we graph it this time, we see that our parabola is up here. There aren't any x-intercepts, and that's why we don't have any real solutions. These are imaginary solutions. Remember, there's a difference between real and imaginary. Since the negative is on the inside, we have imaginary solutions but no real solutions. So I don't have any x-intercepts. We look at our next quadratic formula question. Again, we want to start in standard form, so we've got to move everything over. So we've got 2x squared minus 12x plus 18. I always make it so that my x squared term is positive. If not, you're going to have a couple more problems there. So we have a is equal to 2, b is equal to a negative 12, and c is equal to 18. I want you to press pause and go ahead and try doing the quadratic formula and graphing this last one. All right, let's see how you did. First, double check, make sure that you have all of your numbers substituted in correctly. When you break down that radical, those numbers inside, you get a 0. Well, the square root of 0 is just 0. And it doesn't matter if you add 0 or subtract 0, the top number is still going to be 12. 12 divided by 4 is 3, giving us one solution at 3. When we graph this, we see that we have one x-intercept at 3, 0. So we have 3 different cases here. We had a graph that had 2 x-intercepts, a graph that had none, and a graph that had 1. And we noticed that in our first one, we had 2 x-intercepts, 2 solutions. No x-intercept, we had no real solutions. We have 2 imaginary solutions, but no real. And last, we have 1 solution and 1 x-intercept. On the back page, we are going to look more closely at the discriminant. And the discriminant is b squared minus 4ac. If you remember the quadratic formula from the previous page, the discriminant is simply the piece that is inside that square root sign. So the discriminant is just that number that's going to end up underneath the square root. The discriminant is going to tell us a lot about our problem. When we look back at the first example, flipping back and forth here, the number underneath the square root sign was 169. It was a positive value. And when you took the square root of that positive value, you added a number and you subtracted a number. So when the discriminant was positive, we got 2 real solutions. On the second example, we had the discriminant was a negative 56. When it was a negative, we added, subtracted, but that was an I value, so we had 2 imaginary solutions. And our last problem, the discriminant, the number underneath that square root sign, was a 0. And when the discriminant is a 0, we had 1 real solution. So you can determine how many solutions you're going to have simply by looking at the discriminant and the discriminant only. We look down at the bottom, find the discriminant, and state how many solutions it has. So we need to look at the a value, the b value, and the c value. And remember, this is just b squared minus 4 times a times c. So we've got 6 squared minus 4 times 9 times 1. So our discriminant value here, 36 minus 36, the discriminant value is 0. And according to our chart up here, if the discriminant is 0, we have 1 real solution. We look at the second one. We move that 4 over to get 9x squared plus 6x minus 4 equals 0, giving us a is 9, b is 6, and c is a negative 4. We square our b minus 4 times a times c, and we've got 36 plus 144 because minus a negative. We get d is a positive 180. Since our discriminant value is positive, we're going to have two real solutions. And last but not least, our a is 9, our b is 6, and our c is 5. So we've got 6 squared minus 4 times a times c, which gives us 36 minus 180. So our discriminant value is a negative 144. Because it is a negative number, we're going to have two imaginary solutions. So just by looking at the number that's underneath the square root, we're going to determine how many solutions the equation is going to have in the end.